Welcome to the OpenJ9 community call for June 27th. If you haven't already, please remember to add your name and company affiliation to the minutes so we can track who's attending. And today we're going to have a lightning talk from Cheng. So Cheng, if you want to take it over the screen sharing and start, feel free.
Sure. Start with my slides. Second. Can you see my screen, Pete?
Yeah, we can see it. It's not in presentation mode, so we can see the whole window.
So hold on a second. How's it?
Yep, that's better.
Okay, cool. Good morning, everyone. My name is Cheng Jin from OpenJ9 at IBM Ottawa. So today, this topic is about foreign link APIs, which is a key part of the project Panama we have been working on over recent years. I'll start with some background of this project and then go through a couple of examples from a user perspective to see how it works, and end up with a brief introduction of what we did in OpenJ9. Foreign function interface of FFI is widespread terminology. It's describing a mechanism of how one programming language interoperates with another language. Generally, it means to invoke the native code from dynamic link libraries. When it comes to Java, it refers to the JNI, Java Native Interface, which has been used over 20 years. So JNI is the first generation of FFI framework. But the problem with this approach is that you have to follow the JNI specification in writing the native code. So from a maintenance perspective, this becomes complicated if there's a bunch of update in native. The second thing is that there's no easy way to directly exchange data between the Java object and the aggregated data in native, such as a struct, union. So people come up with a couple of solutions to improve that. The typical one is like Java Native Access or Java Native Runtime, which were built on top of the JNI by leveraging the reflection of the generic code to kind of map the object to the native structures. But in this way, developers have to rely on the external facilities to solve the problem within the Java instead of dealing with the case totally from inside. So the better options should be integrate everything necessary to streamline native access. So that's why we have the project Panama. Panama is an open JDK project that promotes the user experience by improving the interoperabilities between Java and other languages in native. This project literally has two parts, which was developed independently. The vector API is something to optimize the vector computations, and the FFM APIs, which we're focused on. This includes the foreign memory access and foreign linker APIs, plus a tool used to generate the binding code from native. From a roadmap of the FFM JEPs, you can see the foreign memory access APIs was developed ahead of the foreign linker APIs, because the first challenge of this project was to solve the problem with safe access to memory. These two APIs were merged into one JEPs since Java 17, and it kept evolving from there. Now we have the JEP 442, the third provision for Java 21. Hopefully everything with the FFM should be finalized in this version. Foreign link API is a second generation of FFM framework in Java to supporting the data access. One of the most important features they come with is a pure Java APIs for native access without a sacrifice of the performance. That means the developers should be able to invoke the native simply with the Java code without any rules or protocols in native code, because there's no restriction at all for native code. To accelerate the development, there's a tool called JExtract to generate the binding code from the native headers. The binding code can be directly inserted into your applications. This helps to developers save quite a lot of time and efforts writing the Java code. I will explain later how it works with the tools. Now with the tool, it should be straightforward and easy to leverage the existing or letter C libraries writing the C or C+ code, like scientific or mathematical relationship, related computation, GPU and AI native code, etc. Now let's have a look at examples of how it goes with FLA. This is a pretty much simple example for down code from Java to native. The fundamental differences come from the native code and the Java code. In Java code, the first things to settle down is where to place your code for native access. Generally, it has to be in the try blocks of an arena, which literally control the life cycle of the memory resources. That means if there's any memory allocated within the block, it has to be released automatically before leaving the try block. The native address is allocated with a native memory to make sure it can be accessed in the JVM. So the down call is enabled by generating a down call method handler, which is the key to the FLA, because the native invocation is totally based on the OpenJDK method handle. You can see there's nothing special in the native code as compared to the generic C or C+ code, because there's no rule for native code. There's no dependency from a JDK to generate the shared library. Everything there is the same as what I always do with a normal native code. So I think this is one of the biggest advantages of FLA to help the developers in writing or maintaining the native code. This is an example for struct in ARPCO. Compared to the code with the primitive, the big difference is how to allocate and access the structured memories. In terms of the memory allocation, you don't have to worry about the primitives because mostly just passed by value, so there's no need to allocate memory for them. But things different when it comes to struct, because you have to make sure the struct can be accessed in native. So the struct must have a real address in native memories. For the memory access, naturally, there's a two-way to do that. Number one, it can be accessed directly by specifying the memory offset, because the base address is already in there in the struct. And number two, it can be accessed with a while handle. This is a more preferable because it avoids make any mistakes in computing the memory offset in the struct. And the rest of the code remains the same as the code with the primitive. This is a simplified FLA framework, but it shows a key relationship between these artifacts and how they interact with each other to get jobs done. From OpenJDK perspective, FLA is a huge independent artifact built on the top of the OpenJDK method handler, because it needs a method handler to do the native invocation. And it also relies on the foreign memory APIs to allocate and access the memory for the aggregated data. When performing the downcall or upcall in applications, you just need to use public linker APIs, suffice OpenJDK when it hold on a second. I forgot one thing. Sorry. The last example I want to show is how to invoke the native from standard C libraries. So the library is already loaded at runtime because there is no need to specify the path. The only thing left is to set up the method handler for the native. But you don't have to do this in your code. The best way you can do is to leverage the JExtract to generate the binding code for method handler for the native headers, which is pretty useful for the existing libraries because there's no need to modify anything at all. You just use the general codes in your applications, and that's it. In terms of the libraries, it doesn't have to be the standard C libraries. You can specify any native headers you like to use to generate. So the J-extract definitely helps you to simplify the code by eliminating the efforts on the method handle creation. Let's look at how this is achieved in OpenJDK. So this is a simplified FFA framework, but it illustrates the key relationship between the artifacts and how they are interact with each other to get jobs done. From OpenJDK perspective, FFA is a huge independent artifact built on the top of the OpenJDK method handle, because it needs a method handle to do the native invocation, and it relies on the foreign memory APIs to allocate and access the memory for the accurate data. We're performing the downcall and upcall in applications. You just need to the public link API specified OpenJDK, which eventually goes to the underlying implementation in OpenJ9. libFFI, this is open source native memories, a native library supporting the FFI invocation on many platforms, which are already used by the GNI in OpenJ9. So it's natural to leverage this native libraries in FFA because it is easy to extend the support to a new architect in OpenJDK by just add a small piece of code with all the platform details hidden in OpenJ9. What we did for the downcall is encapsulating the libFFI procedures with the method handlers. It includes the FFI data preparation for the arguments and return values and the native invocation. To enable the FFI call in native, the native address is bound to the method handler to ensure it can be used by the libFFI, and the data information for the arguments and the return value are extracted from a function descriptor, which define the OpenJDK and describe defining OpenJDK. So let me show the next slide. Sorry. Okay. So there is a function descriptor which defined in OpenJDK. This describes the native signature. Another thing we care about is to keep the native address alive in a downcall. So we have a code there to control the life cycle of the native address to guarantee it's never released during the downcall. For the upcall linker, there are 2 steps to do that, except everything needed for downcall. Because upcall is a part of downcall and a triggering the downcall. The first step is something similar to the downcall. We still need to parse the layouts of the signature to generate a simplified signature. This signature is used by the upcall thunk. So the ultimate signature is totally different from the downcall signature. We have a special algorithm in there in the native code to generate the native signature. And most important, a thunk is generated for the upcall, a thunk. So the whole idea is a thunk is triggered with an upcall address in downcall to call the dispatcher with all the arguments passed in from the thunk and to perform a calling to the interpreter to fetch up the upcall. The dispatcher's job is to wrap up the raw data from native functions before the upcall and extract from the return object after the upcall. This is extremely important for the object like a struct or pointer. And this structure also helps to dealing with any platform specifics like AX. We have code there to deal with a case like big endianness or little endianness. Well, I think I already covered everything I like to talk in this topic. Back to Peter.
Great, thank you. Does anybody have any questions for Cheng? All right, we'll move on to the regular agenda. Take a look at the user raised issues. slow performance writing records to JDBC data source. Although they were on a very old JVM, I've asked them to try a newer JVM. That's the only thing this week. Does anybody have any particular user raised issues they wanted to discuss? So for Java 20.01, that release is done. The website's updated. The release is announced. For 0.40,
Before we leave that, when I last checked, the binaries were not available via Adoptium. Has that changed, or are they going to be available?
Adam, do you know if Adoptium is going to host the host the binaries from the API?
Dragon 20.01?
Yeah.
Adoptium, no, because they only host CE. Adopt OpenJDK, there was an issue with the API. It wasn't picking up the release. John from Adoptium responded last night and said that should be working now. I haven't tested it, but it was also not working for the Semru API. So I was wondering if there was something else going on, if there was something incorrect in the release, or if there was a code change needed or what. So I'll have to test it again this morning.
And actually related to that, IBM was going to have, the equivalent to the Adoptium API for access to binaries. Has that ever been sort of sorted out? And
it's there. We never really advertised it because it's not quite ready. There was some other stuff we want to do with it, and there were some open questions. And then we ran out of cycles, so it never really went anywhere. It might come back again someday.
Well, I'm just thinking, so right now we're fetching a boot JDK, or we're getting a hotspot boot JDK or a Tamarind one, I forget which. And I was going to update that to get an OpenJ9 boot JDK. But if the IBM API is available, maybe we should just switch to it if that's going to be available earlier than the Adopt OpenJDK version would be.
Right. So there was another, I think it was Costas, had PRs open for that because he hit the same issue. And that's how I started down the road of realizing that 20 wasn't working. So he's got PRs ready for that once they're fixed. But in terms of Semru versus Adopt OpenJDK, they should be equivalent in terms of when they'd be ready because we pushed to both places at the same time. So if we switch over or not, I don't think it matters.
Okay.
So I'll.
But we're still relying on this API and Adopt OpenJDK. It's not going to be brought forward to Adoptium. You can imagine Adopt OpenJDK might eventually go away. So
right.
It might be smart to use the IBM API if we can.
Yeah. Well, our usage is the least of our worries because there's a lot of other people that are using it. So yeah, I don't think they're going to pull it without having a plan with us first. So
okay,
they know we're reliant on it. But yeah, it should be done at some point.
okay, thanks.
Okay. So I'm looking at the 0.40 release. We're waiting for a few changes to be merged into the 0.40 branches. I think Marius, you're on the call. You had made a comment in the issue about changing the API used for computing code cache size in low memory environments. You're still intending to put that into 0.40? Anybody hear me?
Yep, I think we cannot hear Marius.
Okay, Marius, if you're talking, you're on mute. You're not paying attention. So I'll just open up the milestone plan here.
Can you hear me now? I guess the,
Yeah.
the
Yeah, we
laptop
can hear you.
was entirely on mute. So starting with 040, the cheat code cache is going to be limited to 25% of the physical memory available to the process. And this change was needed to address runs in small containers where memory availability could be very low. The initial implementation was done on the physical memory visible or free available memory when the JVM was started. But we thought this may create problems if when the JVM starts, another process on the system consumes relatively a large amount of physical memory, and therefore our JVM sees a very small amount of physical memory. So we changed the API to not use free available physical memory, but rather the physical memory that the process is limited to. I'm not sure if I was very clear. So a process, let's say, that runs a container and is limited to, let's say, 256 of megabytes of memory. However, if on the machine there is another process that consumes most of the free memory, then our process is going to see a very limited amount of memory, so maybe 10 megabytes, and that was we thought is not limited to 10 megabytes, but rather to a fraction of the 256 megabyte, which is the limit for the process. So this is the extent of the change.
Do you know when you'll be ready to put it into the 040 branch? Because we were supposed to start.
I already created the PR. It's ready to go. I pinged Erwin to merge it.
Okay,
Waiting to be merged.
sounds good. And I don't see Daryl. There's another PR that we're waiting for as well. And then there's a OpenJDK crash and compiled method that we're not sure the status on. We need to figure out if that's supposed to block the release or if we're just going to move that out. And then we had some interesting CRIU failures on XLinux last night, but I think we just have a bad machine. I hope we have a bad machine, or I know we have a partially bad machine. Not sure we should be getting the crashes that we're seeing, but it seems like the machine's not set up properly to run CRIU. So we'll start M2 as soon as we get the last changes into the branch, hopefully tomorrow. Anybody have questions, concerns about 040? JDK 21, I can't see us being ready to branch on July 21st. But I guess we'll see how it goes. There's some APIs that are missing and FFI work that needs to be done and maybe some JEP works that needs to be done. I don't have a good picture of all the work that needs to be done. There's something like 50 something items in the milestone plan. So we just have to work through those and start running the tests regularly and getting the test suites to be running green. I think we've made some good progress for Sanity OpenJDK, which I believe is green now, and Sanity functional should be down to about one issue, but I need to double check. And then we need to try the other test suites and see where they stand and clean them up. Cheng, did you want to talk about Panama at all?
In terms of Java 21, we actually already just finish up the code changes so far in terms of existing functionality. But in Java 21, we still need to support unit support. That should be next step. I'll need to prefer looking into that.
Okay.
It's a big change over there.
Anyone have anything else for Java 21? Adam, anything to say about machines?
Starting to do capacity planning for 21, so that's in progress. Other than that, business as usual. That Cent 7 that you found yesterday,
Yeah.
that's a dupe. That's a dupe of another issue. I just commented on it. Marty was working on it. That's why it got re-enabled. So we missed taking the labels off before he started working on it. So that's why he was landing jobs. So hopefully he has it fixed this week.
Yeah. Is it so? It's a new machine or just a machine that we're updating, or?
It was from when the UNB outage happened. It came back up missing a whole bunch of tool chain. So don't know why, but we're basically gonna copy tool chain from another machine onto it. So it was missing like half the compilers and CryU, and I don't know what else yet.
Yeah. Okay.
So I see you have it disconnected. I'll bring it back up, but I'll take the labels off first.
Yeah, it was still running a test.
Yeah, it's idle now.
I didn't finish disconnecting it. Ah, lost my browser. Come on. Okay, anything else?
I think that's it for me.
Okay, Maris, you gave us one update about JIT server. Was there anything else you wanted to talk about?
For JIT server in 040, we'll have the ability to connect to G server after restoring a chain pointed image. So coexistence of G server and CRIU will be enabled in 040. Another change not coming from us, it's around the Liberty operator. So Liberty operator has been updated to be able to deploy and manage G server instances in an instant-on environment. So connected to the previous point. And the third point is we are working now towards elimination of the requirement to have a share class cache present at the client when wanting to use G server AOT cache. So support for using the G server AOT cache without a share class cache.
Anyone have questions about JIT server? Toby, anything about CRIU?
Nothing news to discuss this week.
Valhalla? Anyone want to talk about Valhalla?
Yeah, so for the Polo attribute PR, it's already open and it's being reviewed.
Sorry, I couldn't make out what you were saying at first. You said something about a PR?
Yeah, so for the preload attribute PR, it says it's coming through, it's already open and it's being reviewed.
Okay. Anyone have anything else? So I put there'd be no call next week because I think there's a vacation day so for everyone. So we'll see everyone in 2 weeks. Thanks.
Thank you.